but what about this? And she's like, no, probably not a good fit. So now I have to decide if I'm going to try to write it anyway, or just give up and walk into the ocean.
This is Audiomunity, a podcast about our body's never-ending fight with the outside world.
Hello, everybody. My name is Matt Woodruff, and welcome to Audiomunity, episode number 45. It is August 19th, 2025, as we're recording today, and our episode today is brought to you by you, our listeners, and robots. Robots. They're coming. Robots.
Yeah.
I am joined today by my faithful co-host, who has been the primary co-host of the last several episodes. You've noticed a rotating cast of me and Kate. We do not seem to line up our schedules well. Kevin Bonham.
Hello. I've been watching, I don't know if you know, the Apple TV series Foundation that's based on the Isaac Asimov series that's about like robots, like, you know, the different, well, Foundation is about humans, but there is a prominent robot character. It's a little bit malevolent. I feel like it's sort of appropriate sort of stance towards robots for this episode.
Yeah, no, I think that's fair. And speaking of malevolence, you know what we haven't done in a while is what's good in science 2025.
We have not done. Kate and I took a little digression to talk about scientists losing their minds, but I'm happy. Let's talk about what's good about science in 2025.
Continues to be nothing, Kevin. Continues to be nothing. So a number of things happened. Perhaps our listeners are aware of over the past 2 weeks. So I work at Emory, specifically within the Emory School of Medicine. And up the street on Clifton Road is the CDC. So where I used to work as a postdoc, you could look out from one of the side windows in the building, and you could actually see the CDC campus, which is
and
a really
did something
cool thing.
happen at CDC campus?
Yeah, so a couple
recently?
things have happened at the CDC campus.
All fun and delightful things, right?
Yeah, no, really, really good stuff for the public servants that help make sure that our water is free from lead, that we continue to be able to track infectious disease, and make sure that, you know, domestic violence isn't getting out of hand in our country. So those folks, not this past Friday, but the Friday before, were shot at 500 times by a guy who was upset because he felt like the COVID vaccine had made him sick. He felt like the best way to handle that anger, which, by the way, is a direct reflection of the nonsense coming out of the current administration.
Yeah, his ideas didn't come from nowhere. Let's be clear about this.
Yeah. He felt like the best way to handle that anger was to find several long guns and camp himself out in the CVS, which I've got an employee who was actually at that CVS at the time, saw the guy run out 50 feet from himself, which is cool. Fortunately no one was killed. From the CDC, there was actually a police officer killed who responded to the event, and the gentleman who was doing the shooting seems to have killed himself in the attack.
But, Blue Lives Matter, Matt.
Right.
You know.
Do they now? Because I haven't heard anything.
Well, it depends on who those blue lives are protecting.
Right,
really.
Right. I forgot that was the qualification that we've always had, which would explain why the President of the United States has not actually addressed that shooting in any way or condemned it. That's an important consideration. So, beyond the snarkiness of everything that I just said, that same day, we learned that, actually a couple days before, we had learned that $500 million of federal funding was being stripped from mRNA-based vaccine development. I've got a collaborator here at Emory who was part of that BARDA program trying to accelerate, again, vaccines and therapeutics into the public realm. So that money has all been pulled, $500 million there.
It's not as if that is potentially one of the greatest public health interventions of the last 50 years.
Yeah.
I feel like I mentioned this to Kate. I feel like it's like antibiotics, vaccines, mRNA vaccines. Like, they're not only for infectious disease, but also, for cancer and for like all kinds of other. Turns out if we can manipulate gene expression, we can do a lot of cool shit, biologically speaking.
Yeah, I would put basic sanitation up on top of there from a public health intervention perspective. But absolutely,
fair point.
I agree with everything you just said. So we learned that you can't turn mRNA into drugs anymore. And then on that Friday, we also learned that the federal government, the Trump administration, has decided to place a White House appointed bureaucrat who will be in charge of reviewing every grant with discretionary funding, which is everything we do, and making sure that it aligns and furthers the goals of the Trump administration. Right? And in that text, that was an interesting thing to say out loud because, that's obviously been happening. We've talked about that before on our podcast. Making it explicit is a different level of like, we're definitely just going to go through your grants and figure out the ones that we like best. But the most interesting piece of that executive order was actually not that. It was the statement that we encourage those people to use their own individual judgment as to whether it aligns with the Trump administration's values or the values of the American people, and encourage them not to listen to other people when making those calls. Like, it's explicit in the executive order that he's going to put people in charge of those grants, and those people are not to listen to anyone as to whether or not the grant furthers their own agenda.
Well,
which is wild.
Let's just be really clear. I mean, I'm surprised that the term Politburo wasn't in there because, like, they're being so explicit about this, right? And, like, to be clear, it's not necessarily about grants that they don't like or topics that they don't like. Although certainly, like, you're not going to get anything funded that's mRNA based.
No,
for example.
That's done.
You're not going to get anything related to, trans health, the health of trans folks. You're not going to get anything related to studying health inequity. But what is implicit in this as well is that they can use whatever reason they want. And so, like, I've been trying very, very hard not to censor the things that I am saying online. Like on Blue Sky or on, I don't go on Twitter anymore, but just like, but at the same time, like, there is absolutely zero reason that whoever these folks are couldn't just do a little Google search, see if someone has ever said an unkind word about the Trump administration or anybody that they like, or said a kind word about anybody that they don't like. I just heard recently there was somebody, like, high-level person at the FBI that was fired because he's friends with a guy that is, like, on the outs. So, like, all of that stuff is just, like, clearly part of this. That they're saying, in order to remove the pernicious influence of woke ideology, in quotes, for those of you that are just listening, we are going to make the millions and millions of dollars that are spent on biomedical research subject to the whims of political hacks that are going to make sure that people that we like get money and people that we don't like don't get money. And that's just, it's just the worst.
What it is, I think, and I've been thinking a lot about this since the announcement. What I think it is the formalized end of academic freedom in the biomedical space. Because You can make the argument that you can continue to independently fund things through private university or through private grants, private foundations, those kinds of things. The reality is that the U.S. government is the reason that the biomedical institution in the United States runs, right? It has become fully dependent on the federal government, and the federal government knows that. It holds all the cards. There will be a handful of labs that try to push those things as headwinds, but it will be immensely challenging to get those studies funded sustainably and get them published, it seems like, even at some point. It's going to be really, really hard sledding for anybody that decides that they are willing to try to continue to do independent science in the United States. Those folks, the ones with resources, will start to look for opportunities elsewhere. This is literally what happened in Germany, right? As the Nazi Party was rising, they started cracking down on scientific ideas. And the result of that was the scientists said, I don't think so, and they left. They didn't stick around to try to figure out how they could get their work through these chokeholds of organizations. And I think it's generous that we would think about these folks that are going to be appointed to these positions as Googling through things. I think what's actually going to happen is a bunch of Doge folks armed with a large language model are going to be scouring the internet and taking huge chunks of grants and putting together an AI-based agent that has been educated as to what American values and the Trump administration look like. And all of those grants will be fed into that agent. They'll be ticked off, and then everybody will flow from there. That is what I believe will happen. Because
probably.
the amount of
probably
work,
that AI agent will be based on Mecha Hitler / Grok, XAI's agent that's on Twitter and likes to talk about white genocide in South Africa. And it's just, and the thing is there's going to be no transparency. So we're never going to know which grants that should have been funded didn't get funded. We're never going to know, what kinds of backroom deals were made to get stuff through, what kinds of kickbacks these people are getting. Yeah, it's just I think it's right to say that this is the beginning of the end of apolitical science.
Yep.
And, I don't know how long it's going to be before they're feeding podcasts with 20 subscribers through these large language models. But if Matt and I don't succeed in science, we won't know if it's because we just weren't cut out for it or if it's because we made statements like this on the podcast.
Yes, we will.
Well, you and I will.
Yes.
The world will not.
Right. Yeah, and hopefully you'll hear from us in other venues.
Speaking of LLMs and science,
yes,
how else might we use LLMs to do really shoddy science here in 2025?
Yeah, you could simply just replace teams of scientists with LLMs and hope that all goes well. So the paper we're talking about today is a Nature paper. It is, to put a little asterisk on it, it is an accelerated article preview. So it has not been formally published yet. So a couple things that means. That means that this paper has now gone through the scientific review process. So there is an author. The lead author here is Kyle Swanson. Last author, James Zhao. They're at Stanford, I believe. And the process here has played out such that they've submitted this paper. The editor has sent it out to peer review. Those peer reviewers have reviewed it. Presumably there have been edits that have been made to the manuscript. And so at this point, the editors have said, or the reviewers have said, yes, we believe that this paper has scientific merit and should be published in Nature. So Nature, in order to get the information out faster, sometimes will offer this accelerated article preview, which basically means that this is the science that has been reviewed by the reviewers. but it has not gone through the Nature editorial team to make sure that, for example, all the formatting is appropriate for Nature. It hasn't been trimmed to length, which can be an exceedingly painful process. There are a number of different things that will happen to this manuscript before it actually gets published in the journal Nature, which, as you know, Kevin, is a print journal as well as an online journal, which takes its own considerations.
And to be clear, though, the expectation is that all of that stuff that is yet to happen will not change substantively the content of this paper. I personally think that a lot of folks put a little bit too much emphasis on peer review as like a stamp of approval, because peer review doesn't mostly check for correctness. They don't most of the time try to rerun code and make sure that, they're not doing super in-depth stuff, but they're going to at least say, do the results do the claims in the paper match the results that are presented? Is there anything sort of fishy going on? And basically the answer here is that this has gone through that process at least. So at least 2, probably 3 expert level scientists, as well as the editor at Nature, have gone through this, suggested revisions, and are ready to say this is going to be published.
Right. So this is a relatively straightforward paper. We're actually not going to spend an enormous amount of time going through the figures of this paper, because I think what makes this paper interesting is not the paper itself.
The fact that they got 4 figures worth of little cartoon icons of robots through a Nature paper?
Published in Nature.
Yeah. Oh, God.
Okay.
I've been just waiting for an hour to exclaim about that.
I would like to immediately move to figure 1. I motion to move to figure 1. So
yeah, let's do it.
Okay.
Let's do it.
So here's the backstory. There is this cool concept called meta-governance out in the world. And meta-governance is this idea that what you can do is you can sort of take different AI-based agents. And so when I say an AI-based agent, what I mean is when you're talking to ChatGPT, and if you haven't, you should, because it's coming regardless of whether you wanted to or not. You should really have a conversation with AI at this point. You can have a conversation with ChatGPT and you can ask it questions, right? And it will respond to you as the fundamental algorithm ChatGPT is programmed. I don't know if you've heard, Kevin, but there's been a lot of backlash recently because ChatGPT 4 transitioned to ChatGPT 5, and ChatGPT 5 was not as friendly as ChatGPT 4, and a lot of people had really gotten used to that sort of friendly, slightly sycophantic interaction. So there's an enormous amount of backlash because it's got its own personality sort of encoded. But at the end of the day, right, it's responding with the full knowledge of all the training data that it was given, right? So fancy Microsoft Word fill in the blank what comes next, but just based on the entirety of human knowledge on the internet, essentially. So you can do that, or what you can say is, hey, ChatGPT, I would like you to respond to me as Mozart. And then ask it a question. And what it'll do is it will go in and it will think to itself, well, what would Mozart sound like if it was answering this question? And then it will still use the entirety of human knowledge on the internet, but now it will play it through that filter of what it thinks Mozart would have said in that circumstance, right? So you've created functionally in that case of an instance of an AI agent, right?
I want to pause, just put a pin in a bunch of the phrases that you've used, like it's thinking, it's deciding, and stuff like that, because it's relevant for the paper as well. I want to come back to that, but please carry on.
Yeah, and I'm going to
we'll get into it. I want to just flag that it is very easy to talk about these things with a lot of anthropomorphization.
Yes.
And I think that the degree to which those analogies of thinking and deciding are relevant is a huge, wide open question that I think we should come back to. at some point.
Yeah. So I'll apologize.
But it's very easy to slip into that, and it's in this paper, and I just want to I want to come back
so
to that.
I'll probably continue doing it because I think it's easier from a conversational perspective. But any anthropomorphizing I do is probably
take it with a
not
grain of
actually
salt.
based. Yep. So you have this meta-governance structure. So imagine you need to know, you have an idea, and you say, well, boy, it'd be really good to bounce this idea off of somebody that knows social media really well, or somebody that thinks about fundraising a lot, or, right? Now, you may not have access to that kind of expertise, but with these large language models, you do kind of, right? Because what you can do is you can ask ChatGPT to embody an immunologist, for example, that might have ideas about immunology. And so when you ask that AI a question, it'll sort of consider its response within the context of what it understands an immunologist to be. And so now if you have a fundraising question, maybe you don't have somebody with expertise in fundraising, but you do have a model that can sort of channel fundraising expertise. Now, I have played around with this, Kevin, a little bit, as you know, and what I can say is this is generally pretty useful, actually, right? Because it is constantly the case that you run into questions in your daily life where you'd be like, oh, I wonder what an expert in that would actually tell me about that. And what I would say is you get like 80%, right? So you'll get a good sense of what general advice from a group might be without the specific knowledge of the context or how to apply it effectively.
Yeah, I feel like talking about it on a continuum of percentage, I think is actually not the right frame, because I feel like it's very hard for me to talk about this because I feel like it is very easy to fall really hard in the AI skeptic camp. Like, these things are just stochastic bullshit parrots, and never mind the extent to which a human brain is a stochastic parrot, right? Like it is very easy to sort of be completely fascinated and enamored of these things and think that they're the greatest things ever and just totally buy the marketing spin hook, line, and sinker. It's also really possible to say it can't even count the R's in strawberry. That was a previous model. There's a funny thing when ChatGPT 5 came out, people then started asking how many B's are in blueberry, and it kept saying 3, even though there's only 2, and people were speculating that they specifically trained on the strawberry example. And so it's bleeding over this, to be clear, for those that aren't following this, the PhD level intelligence in quotes of ChatGPT 5 couldn't effectively count the number of B's in the word blueberry. That's an aside. But going off what you were just talking about, I think it's really important, if you play around with these things, to spend some time talking to these models about a thing that you particularly are an expert in.
Yes. Because
the thing that they are very good at is asserting with great confidence whatever that they are projecting. So if I go ask it about 18th century history, which I don't know much about, it's going to sound like an expert. It's going to sound like you have in your pocket access to the best historians about this period, and they can answer any question you want. But when you start to talk about things that you are an expert in, or you try to ask it to write code in a language that isn't JavaScript or Python, all of a sudden you start to see it will just confidently assert things that actually aren't true. And then you're like, actually, that's not true. And then it'll go, oh, you're right. I'm so sorry. Here, let me give you another thing. And it's a very different experience.
And it still won't be true. When it
Many
does
times
the
it
second
still won't
thing,
be true.
Right. And then it'll eventually say, actually, I'm not very good at that, right? If you really press it. So here's a funny example. I write a newsletter for an organization that I'm part of. And we have an increasingly diverse group of folks that read that newsletter. And I thought to myself, it would be really cool if I translated that newsletter so that people that are not native English speakers can have access to this newsletter, right? So the first thing that I did was I had it translate into Spanish, right? And we went back and forth a couple times, and I made sure that, it looked like it wasn't truncating everything. I don't know Spanish, to be very clear, right? But I do have some friends that are fluent Spanish speakers and good English speakers, and so I passed it along to them. And they took a look, and they said, actually, you know what? This is really good. They changed some things, changed some punctuation, right? Did a couple more things. And so we developed a functional Spanish translation tool within ChatGPT. I have some rules and, I put it in, for the most part, pretty good. We recently began interacting with folks that don't know Spanish, but they do know Farsi. And so I said, well, what a good opportunity. So I went back to ChatGPT and I remade the tool to now include 5 languages: Spanish, French, Mandarin, Arabic, and Farsi. And we went through the same QC checks, all the things that I went through with Spanish. And, we made sure that word counts were similar. We made sure that, that meaning was translated through common phrases, right? So not an exact translation, but, keeping the intent of the thing, right? We very carefully went through all that. And we sent it out, and I started using this translation tool. And then I reached out a couple weeks later to someone who actually speaks Farsi. And she said, you have to stop doing that. Nothing that you're putting together makes any sense at all. So it was correctly giving me the Spanish, mostly because there's enough out there, right? It could train effectively on it. And it was just as confidently giving me back these completely garbled Farsi translations that are not meaningful in any way. And I think that's the real danger of something like this, is you have no way as the end user, unless you have expertise in the thing, to actually know if what you're getting back is real or not.
Right. Yep.
So within that context, figure 1. Yeah. And I would actually like to spend some time on robot cartoon design. Do we think that those were AI generated?
I mean, probably, or at least like, I don't know. I think they could have been.
They could have been.
I think it is very possible that they, or at least like workshop some design through an AI and then.
Yeah, I feel like probably they were. Designed, because I feel like the consistency at which the lab coats are there and like all of those things. But so then my follow-up question is, what is going on in the immunologist's head?
Yeah, he's growing cabbage with some like viral spike proteins.
Maybe. Yeah. Anyway, that's the last I'll comment on these robot emojis. But so we have in figure 1 basically a design of the virtual lab, right? So this whole paper is did I even read the title of this paper? I don't think
probably
I did.
Not.
The title of the paper is "The Virtual Lab of AI Agents Designs New SARS-CoV-2 Nanobodies," which I don't know is an English sentence.
No, because it's the virtual lab is the title of the thing. It's not
right.
Like article virtual lab. It's the virtual lab. And then it's saying of that. That's the way that I interpret it.
The virtual lab of AI agents designs new SARS-CoV-2 nanobodies.
Mm-hmm.
Like, it's not like that's like an article from a newspaper, right? Like the virtual lab did it. They designed new nanobodies.
Yeah.
Anyway, it's weird. The phrasing is weird.
Totally weird. No,
but the
doubt.
point, I think the point of that is pretty apparent. They designed this virtual lab structure, and the idea was that they would take this virtual lab structure and by creating these different AI agents, create new potential therapeutics for SARS-CoV-2. So the design of that virtual lab is interesting. So you have the human researcher, right? In figure 1 there. You have the human researcher, you have then two different subcomponents underneath the human researcher. You have an AI agent emulating a principal investigator, and you also have a scientific critic. So the idea here, which I think is a good one, is to have an AI agent that explicitly just calls out potential problems in the overall project and design and stuff like that. So totally fine. So the principal investigator then would go to several different AI agents. And actually in the paper, what they describe is that they basically only imbued the principal investigator to start, right? So the human researcher created the principal investigator and the scientific critic. From there,
I feel like we should use magical terms that he's summoned or instantiated.
Yeah, yes, exactly. The human researcher existed, a principal investigator, from nothing. So then basically got feedback from the principal investigator to create these other agents, right? So clearly this looks like a conversation between the human researcher, I assume, based on the contributions, that this is Kyle Swanson, who is a computer science PhD. So there was a conversation had with the human researcher and the principal investigator, which said we need to identify other AI agents that would be useful in the process of creating these new SARS-CoV-2 therapeutics. They identified three. They have identified an immunologist, a machine learning specialist, and a computational biologist. So they are summoning me and you and maybe a computational biologist. I'm going to put you in the machine learning specialist.
Thanks, I'll take it
right
sure.
now. Yeah, some fusion, right? But that's the idea, right? So they don't have access to these people in producing this thing, or not at a fast enough pace, and so instead we're going to replace me and you with these agent AIs. Okay, and so then essentially what's going to happen here is a series of meetings are going to take place. Those meetings are
just
going
every
to happen.
single word that comes out of your mouth needs to have little scare quotes around it. Just
No, I know.
what quote happens is that these quote agents have quote meetings.
Right. So, yeah, I'll just do this for the whole rest of the. Okay, so human researcher sits down with the principal investigator, who then has a conversation with the AI team in a sort of lab meeting type format, right?
Mm-hmm.
Like we do in real life.
I keep staring at this figure. Like, listeners at home, it is worth your time to go find this figure and just remember this is in nature. Like,
It's nature.
It's the best. It is among the best journals in the world. It's been published since the 17th century. No, that's not quite right. When did Nature first get published? I don't know. It's been around hundreds of years, right?
Yep.
I don't think my 6.5-year-old could do quite this good a job, but some of the apps that he's using could do a better job. Like, this is just, and I feel bad because I don't want to dunk on Kyle here too much. If I were him, I'd be thrilled to get this paper in Nature. I just think that it's distressing. It's distressing.
I actually think, and I'll say this, because we haven't gotten into the science, I actually think that if we got to the end of this paper and the science was fantastic, I would actually have less of a reactive response to these
for sure.
figures. And I think, maybe we're jumping to the end here for the listeners. I think the problem is going to end up being that in reality, the approach to this is strange from a biological perspective, and the results of the approach are not particularly good at the end, right? And so I think why the reason, and maybe we'll just sort of skip to the why this would get in. I think that the why is because agentic AI is interesting inherently. It is interesting to think about how agentic AI will be used within a scientific context. It is interesting to think about how my job and Kevin's job would potentially be replaced by something like agentic AI, right? This is a formal thing that is coming, and we should be considering it. This is really early days in that, and I think Nature took it because this is an example of what this might look like.
Yeah, if this becomes the future, this paper is going to get cited, a billion
thousands of times, right? And so
by those AI agents writing papers,
right? And I get it, but it is challenging, I think, to work through this as totally serious, but. Nonetheless, what we're looking at here is we are looking at a human researcher essentially talking to a PI, an agentic AI principal investigator, who is then responsible for communicating with these different AI agents and immunologists, machine learning specialists, computational biologists, and coming up with ideas both in sort of a lab meeting format and then in a one-on-one format, trying to answer a basic question about generating improved therapeutics. I think it's actually specifically improving nanobodies to bind COVID-19. So nanobodies are basically just these miniature versions of antibody.
They're like the antibody binding portion of an antibody without all the extraneous.
Exactly. So through this process, right, we have all of these meetings, and at the end, the AI agents are recommending tools that they might need in order to do that work. So, for example, you need a tool to evaluate protein stability. You need a tool to evaluate potential binding interactions and structure folding and things like this, right? And you need a couple different versions of those algorithms to really get a sense of whether you think this is going to work. So basically, the idea is you let the AI propose the tools, have conversations with itself within these different personalities, and eventually iterate into something that ends up looking like a therapeutic. Is that fair?
Yes. I just want to clarify also, just when Matt says that these meetings are taking place, this is the in the machinery of the LLM, these agents talking to each other, right? So they're like, I presume, I don't actually know how this works under the hood, but I presume that one agent, sort of one context, right? Because it's all the same model. It's all the same LLM. But if you imagine having like 5 separate ChatGPT accounts open, and you paste in a prompt to one, you take the output of that, you paste it into the next one, you take the output of that and paste it into the next one. That's essentially what's happening behind the scenes, is my impression. So you have these sort of different context windows all chatting with the same model, just back and forth. It's just the model chatting with itself. And that's where, and then there's like periodically the human will come in and like read through and I don't know exactly, do some selective process or clarify things or whatever. But that's when you say these conversations are happening. I just wanted to clarify that's what's going on.
Yep. Yeah. So basically, if we go from there to figure 2, we sort of get to the way that this is actually going to work. And it's basically an overview of everything that I just said.
Quote, figure 2.
Figure 2. Yes. Which is based on Kevin's scare quotes. If you haven't read the paper yet, you can imagine is filled with more robot emojis. Mm-hmm. But we have the team selection, and then we go through project specification, right? So we're basically sitting down at that team meeting and saying, here's what we're going to do. We're going to modify existing nanobodies, and we're going to modify them in such a way that we hope that the results of that modification are going to be increased binding, not only to the original strain that those nanobodies were generated against, but also potentially subsequent strains. And this is what they use as the justification for the science. COVID-19 keeps mutating. It outruns therapeutics. So maybe we can use agentic AI to come up with novel strategies for basically solving this antigenic shift, antigenic drift problem. But they start with 4 nanobodies, right? And these are all Wuhan binding nanobodies, right? So these are original strain SARS-CoV-2 binding. So Taiwan, H11D4, NB21, and VHH72. Now here's an important point. The AI did not come up with those nanobodies. It didn't come up with the overall strategy. They didn't say to the principal investigator, I want you to create a new therapeutic that would allow us to target not only Wuhan, but also all subsequent and potentially future strains. Go. That's not what happened. What happened was the human researcher said, we want to do this thing. We want to start with nanobodies, and we want to specifically start with these 4 because we need to limit our search space significantly, right, in order to, we think, get progress out of this project. So then that team sat down and said, okay, well, if we're going to be doing that, if we're going to be modifying nanobodies, right, hopefully with increased binding, we need a couple different tools, and those are the tools I just mentioned. They use ESM, which is a chemistry stability protein tool, basically, an AlphaFold multimer, which is Google's basically omnifolding technology, and Rosetta. And those 3 things, and Rosetta is sort of like a modification after the fact, right? It allows you to take those structures, right, and sort of play with them.
Rosetta is like old school free energy modeling of protein sequences. So this, I mean, Rosetta in some form has been around for a long time. The idea is that like we know how molecules with free, like how molecules interact and how amino acids interact. So when we're thinking about a protein fold, what a protein fold is doing sort of physically is trying to minimize the energy of the structure. And that happens when like positive charges come next to negative charges, when all the hydrophobic stuff comes together, so it's not interacting with water. Rosetta is a way to model all of that. And it's really hard for Rosetta to go from a linear string to a complete fold. And that was a really hard problem. What AlphaFold does is it basically takes what is known about protein structure and like uses a sequence to predict a fold. But you and I, like years ago, we got kind of excited about this. And one of the first things I did with AlphaFold is I took a globular protein where on the internal surface of the globular protein was a disulfide bridge, which is where 2 amino acids are bound by a covalent bond, right? The sulfurs from adjacent serines inside are bound by a chemical bond. And I mutated one of those serines, forming this disulfide bridge, to, I think, like a tryptophan, which is a giant aromatic thing. So basically, what this mutation should do is blow apart the interior of the protein. AlphaFold predicted the exact same structure, essentially. Yeah. Because that mutation would never exist in nature, right? That mutation would never be in the training data.
Cysteines?
Cysteines, thank you. Yeah, not serious. Sorry.
Sorry, I thought if I let that stand, it would all sound stupid.
You. All right, let me go back. No, that's fine. We can leave that in. So they both start with a sound.
Yeah.
One's a C, one's an S, but ignore it.
In there.
Thank you. And it's a sulfur bridge. So serine. No, that's an answer that an LLM would give. Yeah. Anyway, so I mutated one of these cysteines to a tryptophan. This should blow apart the interior of the protein. AlphaFold didn't understand that because it is trained on real protein folds. That mutation would never exist in nature because that protein would not fold properly. It wouldn't be selected. It wouldn't exist in the training data. Rosetta would understand because that's going to like cause this huge increase in energy, and it's trying to minimize the free energy of this molecule. So what they do is they sort of like, they say they relax it. So basically they sort of like computationally let it kind of unfold a little bit, and then they let Rosetta sort of resolve stuff. So anything weird like that is going to cause it to blow.
Yep. So those are our 3 tools. We then go ahead and we implement ESM, and essentially what they're doing is they're starting from those 4 nanobodies, and they're saying if we do a point mutation scan of the nanobodies, where in those nanobodies do we get better stability? So they're not selecting for
binding stability
the interaction with the spike at all. They're performing point mutations on a sort of through a scanning process and asking the question, what does that do to the stability of the nanobody protein, right? Which
I thought they're using multimers so that it can bind. No.
So what they're eventually doing. What they're eventually doing is we are resolving it onto that multimer, but the initial scan to incorporate those point mutations is actually in no way related to the binding partner of the nanobody.
Okay.
And they say that, and let's take a pause for a second to find exactly that sentence.
Under Rosetta usage, line 724, it said, the computational biologist was also responsible for using Rosetta to calculate nanobody spike binding energies as a metric for measuring the quality of each mutated antibody. So it may be that they're not using ESM to score that, but the joint score of this whole process does include binding.
So that's an output metric
that
they're getting from Rosetta, but it is not incorporated into the actual selection. So when they made those 92 proteins, they used that. Let's just find it real quick here. I thought I had highlighted it.
The machine learning specialist agent was responsible for writing a Python script to identify the most promising point mutations based on the ESM log likelihood ratio of the mutant sequence compared to the input sequence.
Yeah. So in the workflow, first, ESM computes the log likelihood ratio of each single point mutation in the nanobody sequence compared to the input nanobody sequence, with higher ESM LLRs indicating better, e.g. more stable nanobodies. Then the top 20 mutant sequences by ESM LLR are combined with the KP3 receptor binding domain and processed by the AlphaFold multimer, which predicts the structure of the complex of the 2 proteins and computes the interface. Right? So what they're doing basically is doing a random point mutation, finding the 20 most stable point mutations, testing those and putting those into the multimeric structure, right? So that first selection event is actually not in any way related to antigen binding potential.
Yep.
Right.
Yeah, and also I think it's worth just looking. I don't know. I think this is their methods. The stuff that the computational biologist actually wrote. Like, it's important here that, like you were saying, like the agent wasn't choosing the problem. Based on the thing above here, I think it actually did choose which nanobodies, but I don't think it chose, like, this particular approach. It wrote a 130-line Python script to parse the outputs of the ESM model. ESM is a giant project done by Chan Zuckerberg at BioHub, I think. Tons of scientists involved in doing that, like real-life scientists. It wrote a 144-line Python script to deal with the AlphaFold running and outputs. And it wrote a 30-line Rosetta Scripts XML file and a 71-line Python script to deal with the Rosetta outputs. So, like, it's not nothing.
Sure.
I would be shocked if the first author here, Tyler, didn't have to make some tweaks to those scripts to make them run, given my experience of LLMs for coding. But that amount of work to just like parse inputs and like run, like that's like I could do that like, you know, in 2 afternoons. Like I would put an undergrad on that as like a short project. Like Rosetta is a monumental piece of important software for understanding protein structure, as is AlphaFold. I don't know much about the LLM ESM
Yes.
much, but I assume that it is also like quite a lot of work. The actual computing that was done here is piping together 3 tools and getting some output. That's not complicated. That's not hard.
No, I would say, there's an interesting component of like, how do you know which tools to pipe together if you didn't have any a priori, understanding of this field, which my guess is probably describes at least some of this, based on what I've seen in this paper. I do think, this is the kind of thing that LLMs do really well, which is allow somebody to quickly and efficiently enter into a space that they weren't previously aware of and start to get, some information as to the kinds of tools you would use, the kind of approach that you would take, all of that. I think that that's valuable. I agree with you. If somebody with this kind of background was approaching this problem, it would not be an insurmountable problem. We're not talking about a project of enormous biological complexity here, or computational complexity. But nonetheless, they push it through, and they come up with iterations of this process, so up to 4 mutations per nanobody. They come up with 23 different versions of nanobodies, 23 off of each original of the 4, which gives you 92 total nanobodies to screen. They look at those nanobodies computationally and ask the question, do they look like they'd be more stable? Do they look like they would maintain their interaction space, right? So basically, of these predicted proteins, which is a bit of a tautology because, of course, you're selecting for these things and then you're asking, do they perform better by these metrics? And of course, the answer to that is going to be yes.
Yes.
Which is why the biology becomes really important, right? The question at the end is, do these things actually do what you want them to do, which is to bind to things other than just the Wuhan strain of SARS-CoV-2 RBD. And so they did this first in E. coli. They basically took the nanobody sequences, and we're at, I think, figure 4. They're not actually labeled on the printouts that I have here, but
so figure 4 is the one experimental, which, to be fair, like when I started reading this, I was really worried that they weren't going to get to this. So it is very, very important that they do some like real world meat space experiments.
Yeah.
Not just the computational circle jerk of the rest of the paper. But
yeah, I agree. So we have now taken nanobodies, which have been selected to be more stable than the original input nanobodies, and you express them in E. coli, right? So you're basically taking the soups from an E. coli culture, and you're asking the question, do these nanobodies get produced? So A shows you how many mgs per liter, which is it is a measure of protein stability, I suppose. That is one component of what you would be measuring there. You would not be measuring translation efficiency. You wouldn't be measuring the ability of E. coli to continue to grow while producing these nanobodies, which is a critical factor. So there's a lot of things left out here, but what they do show is that for most of these nanobodies, you get pretty decent yields, right? So you're at least getting mgs per liter, which is not bad at all. And then I think what we have is by far the most important figure in the paper, which is, did you do anything, right? You've produced 92 of these things with the explicit goal of increasing the binding affinity of the Wuhan-specific nanobodies into these other strains. And so here they've got Wuhan, JN1, KP3, KP2.3, and BA2, and BA2 is the original Omicron variant. And they asked the question, of these 93 nanobodies, which ones, and a BSA control. So this is bovine serum albumin. So this is looking for non-specific binding. And the question is, do we have better binding to these, first of all, to the Wuhan strain, I suppose, and also better binding to these other strains. And these are ELISAs.
Y-axis is intensity.
I don't
with
know
0 units.
I do not know. I do not know how you get intensity as a measurement off of an ELISA, unless what you're doing is you are running that ELISA, taking the raw absorbance values, and then putting the top one as 100%, which would really conflate the logarithmic scale of ELISA sensitivity.
Is this even percent? I don't know.
There's no units. It would have to be.
I mean, I was thinking that it was like some luciferase assay, and they're looking at. I'm just Googling through or doing Control F.
I know it's plate based.
Yeah, they cite some papers generally described. Multiplex ELISA measurements were performed as generally described. Array patterns were printed.
Okay.
Spot was printed in duplicate.
Okay, so got it. So these are array spots. So they're taking array spots and they're maxing the intensity out. So I was incorrect. So let me retract all of the things I just said about ELISAs. So you've got a spot-based assay, and you're asking the question, are you getting basically binding to that spot? Which then I understand how you would put intensity as a percentage of 100. It's probably not ideal, but let's go with it. And so the question is, how do these things perform? And what they've got are the unmutated version of all 4 of those nanobodies. And then they've got basically absorbance to all of those different strains. And I don't know, your first impression.
So first thing I want to say is that if binding to Wuhan went down, but you got binding to all of these other strains, that is still a useful outcome.
Yes.
Unfortunately, you basically don't get binding to most other strains, at least not substantially above the non-specific control, which goes up. And so what I feel like these mutations have done is made this protein sticky, so that it will bind to just about any, like in 4B, the BSA dot for the mutant that seems to bind best is basically at the same level as the other 4, as the 4 variants that they tested.
Yeah.
And binding to Wuhan went down.
Yeah. I mean, let's start with the most basic thing. You've produced 92 nanobodies, right? You've compared them to an unmutated control, right? With known Wuhan binding capacity. Across all 92 of these nanobodies, the vast majority of the nanobodies that you produced went down in affinity against that Wuhan protein.
Yeah, but again, like
the vast majority.
If there was an increased specific binding to the other strains, yes, that would be fine.
Yes, it would.
Because this is high affinity binding to Wuhan, so if you get general, that would be... Sure. It's just that you don't actually get...
Right. So the only thing that
binding.
You've done with the vast majority of these nanobodies is kill off binding potential to Wuhan. Right? Yep. So we can agree with that.
I agree with that 100%.
So most of these proteins continue to be stable, which is good, which you'd expect because they're being selected on for being stable. The vast majority of them, though, have lost binding potential to any SARS-CoV-2 binding. Yeah? And we've screened 92 in a lab, right? There was no good indication that the 2 that they highlight, which, yeah, I mean, boy, it's not clear really that any of these are performing particularly well beyond binding to Wuhan. The couple that they mention, there was no reason for them to think that the ones that they screened and they hit were going to be their best potential, right? So what we've done here is we've used a pretty significant number of resources to screen these 92 nanobodies, the vast majority of which are worse than the starting product that we got from the biology. Is that a fair assessment of what we've done so far?
Yeah, I really want to be generous and say that in a couple of cases, they had increased binding to some of the other strains. The problem is that in those examples, aside from like there's one green dot on the NB21 and one green dot on the Taiwan that has some binding to JN.1.
Yes.
And not also increased binding to the non-specific control. But the other ones, like all of the pink and purple dots for H11D4, like the BSA binding went way up. Yeah. So you gotta imagine that this antibody is just sticky. It's just gonna stick to lots of stuff. So like that's not a therapeutic you can stick into a person if you're binding to bovine serum albumin almost as well as strains of SARS-CoV-2. Like that's just gonna like, you're going to get antibody complexes in your blood and you're going to like have serum sickness, right? Like that's just, it's not great. It's not great.
Yeah. And so then they do a titration for the nanobodies that look like they are having, above background signaling, this, 177V to L59E, Q, they're naming the point mutations, so it's kind of hard to go through the actual names, but they do show that you're getting some specificity to that JN.1 RBD, really no specificity as far as I can tell to any of the other strains. So we're really restricted here as to potential biologic utility. It is not clear how one could see taking what has been done here and turn it into a therapeutic. And I think you'd almost have to conclude at the end of this that the pipeline here for generating targets and screening is probably not an effective pipeline. For context, there have been nanobody screens in the field in SARS-CoV-2 that have been relatively successful and have found good nanobodies that cross-protect and those kinds of things. Granted, those are incredibly labor-intensive, they're costly, all of those things, but it is not clear that we've gained significant advantage by instituting this pipeline into this kind of effect.
The thing that bugs me about this is that, like, the thing that bugs me most, I think, is what I think this paper is set up to be used as an argument for is the idea that we can use LLMs to replace teams of scientists, right? What is not specified here? I mean, they have some the little pie charts where they talk about the number of words written by these things, right?
So there's last piece of data in this paper, just to put a point on that, the last piece of data is words written in workflow design, which 10.7% were written by the human researcher and 90% were written by the principal investigator. That is the last piece of data in this Nature paper.
Yeah. But which is absurd. Yes, I agree with that. But what's actually germane here is what is the cost in dollars and in time for this output compared to if you did the same thing with a human, right? So what would have been kind of cool, I think, what would have been a useful thing is to say, we're going to partner with, I mean, like some of the people on here were from Chan Zuckerberg, so they could have used like Llama or the Facebook LLM, gotten information about like, what is the actual cost in terms of like energy and data storage and like compute to run all of these agents, like the actual cost, not the subsidized stuff that we're getting from OpenAI and Anthropic and all of these. Like, what is the actual compute cost? How long did it take this computer science grad student to set this all up, go through the thing, debug whatever scripts came out, run them, etc. Compared to if I hired an undergrad to write some Python scripts and do this. Like, what is the difference in the quality of the output? And what is the difference in terms of cost in time and money? Because the thing that people are claiming is that LLMs are going to replace expert level scientists, right? And if true, that's a big deal. If you can replace a team of 5 PhD level scientists who went through all of the cost of training and all of that stuff with these LLMs, like that would be an important thing to know. But nothing in this paper tells us anything about the comparative cost of an LLM versus a team of humans.
Yeah, I mean, they try
as
to
you
get
say,
that.
the science output isn't great. Like, but lots of like just fine science gets published. That's fine.
Sure.
I don't think that's necessarily a problem. But
I think,
the thing that would make this paper special would be an understanding of how this is different from a human team, and there's nothing about that.
Well, I
No
think that they try a little bit, right? So line, 249, 250. So the analysis of the virtual lab interactions, where they talk about, the parallel meetings taking 5 to 10 minutes of time at $1 to $2 of GPT-4 token cost, total of around 1 to 2 hours to complete all phases of all meetings, right? Factoring in time to tune prompts for each individual phase, basically created a nanobody workflow design in a few days, compared to likely weeks for a human researcher working independently to design and build the same pipeline from scratch. Then it took about a week to run the computational nanobody design pipeline, followed by about 6 weeks to synthesize the nanobodies and 2 weeks for binding experiments. So they're claiming basically that, let's say 3 months. 3 months start to finish, right? For a relatively small team at relatively low end user cost, at least to design the pipeline, put it together, right? Synthesize everything, all of that. Which I think is why it's in Nature, right? I think that the point of this is, it's obviously not to say we've done Nature level science without, a computational biology team. Like they have not. To be very clear, the results here, the biology here, does not belong in Nature. There's no way that you would get data like this into Nature, which means that the reason that this is in Nature is because this is prompting a discussion about what AI agents are capable of doing and how those interactions might help us in the future. As Kevin mentioned, I think that we could have gone a lot deeper into that. I think if that's the point of the paper, then explicitly talk about that a little bit more. Talk about all those metrics that Kevin just mentioned. Because this isn't
if you had a structural biologist look at these mutations, would they be able to pick mutations that would work?
Yeah.
I have no idea. I'm not a structural biologist.
Yeah.
It feels like in the same way that I know if you stick a tryptophan in place of a cysteine forming a disulfide bridge in the middle of a protein, I know that that's not going to... A structural biologist might be able to look at the interface of an antibody or a nanobody and Wuhan spike and make some predictions about some different amino acid changes. I don't know.
Yeah.
That would have been an interesting thing to see.
Yeah, because what you're talking about is benchmarking, right? What you're talking about, like the point of this paper probably should have been about benchmarking. What is the utility of this kind of approach versus the utility of going through the traditional approaches, which rely on human expertise, right, and human interface.
Yes.
I am generally not quite so hard on papers as I have been here today. It's a little challenging to get through this one because the explicit undertone is we don't actually need the expertise in order to get things done. And then at the end of the paper, to not really come out with any product that's defensible within Nature it stings a little bit, I have to say. It stings. It's not comparative. But I would say this kind of thing is inherently interesting because the technology is developing. Yes. It is a discussion that we should be having. I would have liked that discussion to play out a little bit differently here, but I do think that it is an important thing to be thinking about because this is coming down the pipe, right? Like I've become resistant to the argument, well, and you mentioned it before, right? Counting the number of bees in blueberry is funny and it's anecdotal. It is not like we don't have PhD level intelligence here at AI. That does not mean that in 5 years or in 10 years that it won't be. And I think that it is important to have those discussions now while the technology is developing. But I also think that we need to take some humility as we approach it.
And I think here's maybe where we can come back to this question about all of those things that we were saying, put in scare quotes earlier on: intelligence, reasoning, expertise, because it's littered throughout this paper. There is so much of that kind of language that really, really rubbed me the wrong way because it's stacking the deck, right? So, for example, just in the introduction, several studies have explored the scientific capabilities of LLMs by measuring their ability to answer scientific questions, and LLMs have shown high accuracy and can even match or outperform scientists at these tasks. That match or outperform, you have to pay attention to the benchmarks, right? Like you were saying benchmarking before, like the way that you build a benchmark is very, very important. Anyone in computing will tell you it is very easy to micro benchmark things that have no application in the real world, right? Then they say that this is an open-ended interdisciplinary research problem. How open-ended is it? Like, it was pretty clearly specified by the researchers what the actual problem was. It's not that interdisciplinary.
Yeah, and the researchers set the agenda for every single meeting.
Yes.
And I don't think we touched on that before, but all those lab meetings that we were talking about before, the human researcher had to set the agenda for those meetings. They didn't happen spontaneously, right? So at every step, you are actually re-engaging around the framing of the question at the human level.
Yeah, absolutely. They say that we have interdisciplinary AI agents. These agents are all built from the same model. They're all GPT-4 based models. Saying they're interdisciplinary is based on that idea you said at the beginning, where you're just saying, like, take on the role of an immunologist or something, but it's the same underlying model. It's not special training data. They say that the LLM that powers their scientific reasoning abilities. This isn't reasoning, right? Like, well, should be agnostic about that. I think that we don't really understand what underlies human reasoning and consciousness. And there are ways in which LLMs are analogous to the way the human brain works. But I think it's very clear from a lot of other studies in AI that there are fundamental differences between the way that humans reason and the way that these machines reason. And to the extent that I'm not even sure it makes sense to call it reasoning. And I think there are AI boosters that would quibble or that would take exception to that. But I think it is very important that we are skeptical of analogizing these models and humans doing similar thing, because the incentives for a developing human brain that have been shaped by evolution and a long childhood and school and all of that stuff are fundamentally different than the things shaping an LLM, right? The reason that you can have an LLM that now perfectly can tell you how many R's are in strawberry, but screws up with the number of B's in blueberry is because, and you were talking earlier about the personality of GPT, the sycophancy of a lot of these models is because you have humans that are providing feedback on what they like, which responses they like. And people like to be flattered. People like to interact with things that seem nice. And I think that one of the biggest hacks that these models and their producers have produced is this chat interface that tricks you into thinking you're interacting with a consciousness. Because for lots of these interactions, and I would challenge people that are having these conversations with their LLMs to try to imagine Microsoft putting out a tool that didn't have a chat interface, that was just like a command line prompt or something, or a Google search that provided the same factual content as the LLMs, and how quickly, I really imagine that if I put it to Google and said how many bees are in blueberry, and it confidently told me 3, I would stop using that search tool, right? But because it's a chat interface, it's like you forgive people. If you're having a conversation and they sort of spout off some bullshit and you're like, is that true? And they're like, oh, no, you're probably right. Like, you feel a camaraderie. You're like, okay, like we're BSing over beers. You form relationships. And that relationship aspect of these things, which I think it's a cognitive hack. It's not real. You're not interacting with a person, but it feels like you are. I think that is leading to all kinds of interpretive bias that we have a very, very hard time overcoming. And I think this paper, honestly, is kind of an extension of that to some degree. Yeah. It seems very amazing, so it got into Nature. But like you said, like it's just not. It's not good. It's not good biology. So, yeah.
Yeah. You know what it will be good at? Taking huge stacks of grants and deciding whether or not they are
aligned with Trump administration priorities.
With American values.
That
will be a really effective application for that. And I will look forward to seeing that paper published because I'm sure that they are going to academically study how that goes.
You know, here's the thing is that the benchmark is not going to be it depends on what you mean by effective. I know you're being tongue in cheek, but like this is a real problem that if in machine learning, there's this idea of overfitting, right? You can build a model that generates a bunch of output that seems really good, but you're not benchmarking the right thing, and so it doesn't actually produce a correct output. If you feed all of the grants that come through NIH through a machine, it's probably going to eliminate a huge number of them. Most of them would have been fine. The few that get through are going to be fine. And they're going to say, huge success. We managed to let through a bunch of fine grants. But like, we're never going to know all of that unfunded science, what it could have done. Right? We're never going to be able to live in that counterfactual where that science got done. And, that sucks.
Yep.
It sucks.
Yep. So.
And now I have to go and try to work up the motivation to write.
Go enjoy your grant writing. Have fun. All right.
Yeah.
Well,
with that, this has been Audio Immunity, recorded on August 19th, 2025. I'm Kevin Bonham with Matt Woodruff. If you like this show, despite our kvetching and AI doomerism, you should subscribe. You can find our feed at audioimmunity.org, AUDIOMMUNITY.org, or whatever podcatching service that you use. On our website, you can also find links to our Patreon, patreon.com/audioimmunity, a contact email that we set up last time, contact@audioimmunity.org. We have a Blue Sky account that I'm trying to use to post episodes. You can find me and Matt's lab there, although he never posts. But you should get in touch with us in any of those ways. If you like the show or you didn't, let us know. Give us feedback. Share papers that you think are cool uses of LLMs or stupid uses of LLMs. We would love to see all of that. The music at the beginning and the end of the show is composed by Rachel Reinick, and we'll talk to you next time. Take care.
Sometimes